right, let's consider this chemistry question. This is question 16 JAM 1978. During the electrolysis of copper 2 sulfate between platinum electrodes, if litmus solution is added to the anode compartment, A, the litmus turns blue, but no gas is evolved. B, the litmus turns blue and oxygen is evolved. C, the litmus turns blue and hydrogen is evolved. D, the litmus turns red and oxygen is evolved. E, the litmus turns red and then become colorless. Very good. So this is a question on electrolysis. Now, particularly this electrolysis of copper 2 tetraoxosulfate 6. So that is the electrolyte. Using platinum electrode. So normally there are two types of electrode. We have the reactive electrode and the non-reactive electrode, which is also known as the inert electrode. So that is electrode that do not affect the solution. They don't affect the system. So this platinum is a good example of such electrode. And also carbon is a good example of such electrode. They don't affect the solution. They don't affect the electrolysis process. But when it comes to copper electrode and also mercury electrode, both of them are reactive electrode. They can affect. So now we don't have anything to worry about when it comes to platinum electrode. Now, what now happens at the anode is a major concern in this question. So because they said if it is added to the anode compartment. Now, we know that anode is the positive electrode, while cathode is the negative electrode. So during the electrolysis of copper 2 sulfate, so the copper during ionization is going to split into two. Copper, which is CuSO4, this is copper sulfate, is going to split to copper 2 ion and sulfate ion, SO4 2-. So, and you know that water also, there is presence of water inside every acid because acid is always aqueous. So water, which is H2O, H2O2 will split into hydrogen ion and hydroxide ion. So we can leave it like this. You may balance it by yourself, but it doesn't really matter. Now, this hydrogen and copper, they are both the positive ions in the solution, in the system. While sulfate ion, which is tetraoxosulfate 6 ion, so SO4 2-, and also hydroxide ion, they are both the negative ion that we have inside this system. So our major concern is these two. The negative ion, they will migrate to the positive electrode. That is to say, this SO4 2- and the hydroxide ion, they will migrate to the anode because anode is the positive electrode. Now, because of the position of hydroxide ion in the electrochemical series, hydroxide ion will be preferentially discharged at the anode. So that means the SO4 2- will travel back into the solution. The SO4 2- will travel back. Now, this OH- that travels, that is discharged, the OH- that is discharged at the anode, so it will undergo reaction. OH-, you know, this is a negative ion. So negative ion needs to lose electron. So it's going to lose electron to become water, and then oxygen will be evolved. So this is what we have as the reaction. So that means oxygen will be evolved at the anode. That's the first point that you need to know. That's the first point. So you look for option that has oxygen being evolved. So B is the one that likely have oxygen being evolved, and also D also have oxygen being evolved. But we are not done yet. So because if you go for B, this one says litmus turns blue. So can this be true? We'll confirm that later. Then for D, litmus turns red. So we'll confirm that now. Now, Because, when hydroxide ion is taken preferentially, and, SO42 minus that we have will travel back into the solution. Like I said before, it will travel back into the solution and combine with hydrogen ion. Because at the cathode, it is copper that will be deposited at the cathode. Copper will be preferentially taken. So because due to the arrangement in the electrochemical series, copper will be preferentially deposited than before hydrogen. Now hydrogen will now travel back into the solution and combine with the SO42 minus. So it means this will now form what we call H2SO4 acid. So this is tetraoxosulfate 6 acid, which we call sulfuric acid. So this sulfuric acid being traveled back into the solution makes the solution more acidic. So that means at the anode compartment, so there is more acidic solution over there. So because there is more acidic solution, because the solution is more acidic over there, if we add litmus into that part, litmus solution, it means the litmus will turn from blue to red. That's one of the ways of testing for presence of acid, or that's one of the properties of acid. They turn blue litmus paper red. So it means the correct answer to this is option D. That is, the litmus turns red and oxygen is evolved. Thank you. God bless you.